Okay, so here's the practice quiz 2, the second practice quiz for this quiz 4.4c. And here we have a rectangle that's inscribed between the graphs of y equals 4 minus x squared and y equals x squared minus 6. Find the maximum possible area of the rectangle. So you could graph these. It shouldn't be too difficult to graph these, but you could always put them in your calculator if it's a strange one, something that we're not too sure of. So let's just check it in the calculator to see what it looks like. And one is 4 minus x squared. Here's the square over there. And the other graph is x squared minus 6, x squared minus 6. And we could do a zoom 6, I guess. And you have one parabola there, and the other one comes down like that. So we're going to put a rectangle in here. Now most of these inscribed rectangle problems have got to be pretty much symmetrical or centered at the origin, so they'll work out. We can have some off-center ones, but they're kind of rare. Okay, so what I do is I kind of sketch this out. So you can kind of see it over here. So this is the rectangle that's inscribed, okay, between these two graphs. So the vertices of the rectangle, these are on this curve, 4 minus x squared, and then these two vertices are on the x squared minus 6. All right. Now we want to find the maximum area, so what we want to maximize is the area, which is base times height, so we have to have a way of notating that. Well, again, we did this before when it was just a problem like this, where we were just doing it, let's see here, something like this under one curve. Remember, we were trying to maximize the area of that rectangle, and it was on the axis, and then the vertices were on one curve. So we did a problem like this. So now we're just making it a little bit more interesting. So remember, wherever x is, okay, the corresponding heights are going to be here and here. So if I pick an x over here, the actual width of this rectangle will be 2x, because this is going to be x here and that's going to be x there. Okay, so this is x. Any point here. In other words, if x was here, we'd have a taller, skinnier, a taller, shorter rectangle. Okay, if x was up here, it would look something, it would go up like higher. See, if x was there, it would look something like that, down like that, because it's symmetrical. So it'd be something like that. Okay? So x floats around. When x is here, it's going to look like this. So this side will be mirrored by this side. So my actual, I guess, width of my rectangle in this case will be 2x. Or my base. We'll say base times height. Okay? So we could say the base will equal 2x. Now how are we going to find the height? Well, now this is we've got two curves here. Now let's just look at these points just so you can get an idea. Right over here, my height is about 1 1/2, and over here, my actual height looks like it's my actual distance from here to here is going to be 1, 2, 3, about 4.5. Okay, but this is negative. So if I take 1 1/2 minus, and now this is going to be negative down here because this coordinate here would be negative. The y value would be negative 4.5. But I know that the actual length is 4.5. But if I take this top value here, over here, in other words, this coordinate, whatever it would be, I don't know what the x value would be exactly, but the y value, it looks like it's going to be, let's say, 1.5. And let's look over here, and this coordinate, the y value will be negative 4.5. But we know that this length is going to be 1.5 plus 4.5, or 6. Well, if I take 1 1/2, or 1.5, and minus negative 4.5, or 4.5, I'd still get 1.5 plus 4.5, which is 6. So it's going to work out. So basically, we can find this length by taking the top value minus the bottom value, because the bottom value will be negative, and a negative times a negative is a positive. So we'll be doing this again later, actually, when we get in chapter 7. So we can actually find this length by thinking of the top curve minus the bottom curve. So that's something you want to remember. Top curve minus the bottom curve. And that's going to give you the actual length of this segment. And that's actually my height. Okay? All right, so let's come up with the area, with the formula for the area, and I'm going to work it over here. So I'll kind of refer to the sketch. Let's put this up a little bit like this. So we know that area is going to be equal to base times height. And my height is going to be the top curve. H will be the top curve minus the bottom curve. And the top curve was y equals 4 minus x squared. And the bottom curve was x squared minus 6. Okay? And remember, my base was 2x. So let's put this in our area formula. So area equals, my base is 2x. And then my top curve is 4 minus x squared minus x squared minus 6. That's the bottom curve. Top curve, bottom curve. And that's going to give me my height. You can see that there. Okay, so take a look at that. So this is my base here. (2x), and this is my height. Top curve minus bottom curve. And that's going to give me the area, and it's already in terms of one unknown, so we don't have to use a constraint or substitute. We just have to simplify that. Okay, so think about that now. You need to think about it. Okay. We'll go back and review it if you don't get that, because we're going to be doing a lot of this. So this is actually area as a function of x equals 2x times, and this is going to be 4 minus x squared plus 6. So my area as a function of x will be 2x times, and that's going to be 4 plus 6 is 10 minus 2x squared. And then I can multiply this out. So my area as a function of x equals 20x minus 4x cubed. And that's what I want to take the derivative of. Now I'm going to do this a couple of ways, and I'm going to show you a little shortcut or a different way to do this using your calculator. Now this derivative is easy to take by hand, so we can do that. So let's just do it mechanically there. So a prime is pretty easy. That just equals 20 minus 12x squared. Now that's not going to, so we're always going to do the first derivative test, or just check, see what we got. It's not undefined, so we're just going to set this equal to 0. So 20 minus 12x squared equals 0. And then if we add 12x squared to both sides, we end up with actually 12x squared equals 20. So x squared equals 20 over 12. So x equals plus or minus the square root of that, but we're going to just do we won't have a negative x, so we're going to use the positive. So the square root, and then 20, that's going to be reduced to be 5 over 3. So the square root of 5 over 3. All right, oops, sorry about that. So we just solved that for x. Okay, and we could check this. If we take, so this is a 0. If we take the second derivative of this, it's going to be negative. If I take a double prime, just to check it real quick, a double prime of x equals If I take the derivative of that, I'm going to what? Negative 24x. And x is going to be positive, so that means that's going to be negative, so that means it's going to be concave down. So if it's concave down, that's going to be a maximum. So we can check it real fast by using the second derivative test, all right? Because we know over here, it's always going to be concave down, because when x is positive, I should say, this will be negative. Negative times a positive is a negative. So then I'm going to be concave down. So that means I'm going to have a relative maximum. So there's my relative maximum. Okay? So we can solve this mechanically. We can find out what this is because we're going to put this back into our original equation. Because that's going to give me my area. We want to find out what the area is, and that's 20x minus 4x cubed. So now we're going to have to get into our calculator a little bit, okay? And I'm running into a little bit of a time situation, so I think I'll finish this on the second video, and then I'll also show you the other calculator method to do this. But try to follow all the logic behind this and how to set this up, because that's the main thing we want to do. There's a couple ways to actually find the numerical solution of this, so I'll show you that momentarily.